My dear students, today we will discuss about saltdomes and diapires. As the name suggests, salts may occur as domes and they may intrude into the overlying rocks producing diapires. So what is salt dome? Salt domes are thick bodies or cylindrical bodies of salt that are found to be injected in solid state upwards with more or less a circular or domal top measuring diameter of around about 1 kilometers or above with depth extension up to several hundreds of meters. So it presents a huge salt body that is found to move upwards because of its low density compared to the surrounding. So there is a instability in gravity, as a result of which these salt bodies try to move upwards, producing domal structure which we commonly describe as salt domes. And if during this injection or upward movement of salt bodies there occurs piercing or intrusion of the salt layers into the overlying sedimentary formations, in that case the salt body is described as a diapir. So diapir has a discordant relationship with the overlying rock. In diapir, the salt bodies they try to intrude into the overlying rock and try to cut across them. So the term diapir is applied to intrusive salt bodies. This term diapir is actually a Greek word which means to pierce. Hence, salt bodies that show piercing structure are called diapirs. But commonly, saltdomes and diapirs are loosely used as interchangeable terms. Saltdomes and diapirs are interchangeable. Injection of any solid rock, whether it is igneous, sedimentary or metamorphic, it can be brought under diapirs and the process is called diapirism. So how many types of diapirs are there? Generally, we have evaporite diapirs which are commonly called as saltdomes. We have serpentinite diapirs, we have shale diapirs. So, the solid bodies, because of their low density compared to the surrounding, when are subjected to disturbance or deformation, in that case, those bodies try to move upwards. As is the case we see in case of magma. Magma is having less density and when it is being produced, it always pushes its way through the overlying rock to come to the surface. The process is called intrusion. Similarly, in case of salt bodies, because of their low density, they try to move upwards when disturbance takes place or some kind of disturbance that may be in form of tectonism, in form of erosion, which disturbs the balance, as a result of which the salt bodies are forced to move upwards through the overlying sedimentary formations. So salt bodies which are huge in extent, dimension and are found to move upwards are commonly classed as salt domes. So let us see, so what is its composition? Salt dome. What is the composition? Salt domes are made up of evaporites. What is evaporite? It is a sedimentary deposit which is produced by evaporation. So, in marine environment, we find the marine waters which are rich with salt, they undergo evaporation and give rise to deposits of salt, mostly halite, NaCl. Also anhydrite, gypsum, these are the salts. But very common composition of salt domes is NaCl. Argillaceous and potassium rich beds are found to be interpreted with salt. And shale and clay layer, clay sheath, it may be found to partially enclose salt core. And also, brexia locally surrounds the salt core. So, common composition of salt dome is NaCl and to some extent anhydrite and gypsum. The cap rock of salt domes are found to be made up of limestone at the top, it is followed by gypsum and at the bottom we have the anhydrite. the thickness of the cap rock may reach to a maximum of 300 to 400 meters. Thus, in case of salt dome, we have the salt core, mostly represented by NaCl, and it is found to have a cap rock. This is cap rock, which is mostly made up of gypsum, limestone, anhydrite, and this is the typical structure of salt domes. The shape of salt domes are found to vary depending upon the conditions of intrusion, depending upon the disturbance that takes place, depending upon the tectonism, depending upon the erosion of the overlying rocks, and how the salt bodies face a condition of stability, and related to that its structure is being controlled. So salt domes, as the name suggests, it is dome-like. What is dome? Dome is an anticlinal uplift with concaversal dip. Concaversal dip, more or less uniform dip outwards. That is called concaversal dip. So here, in case of the salt domes, the salt is found to move upwards like a cylindrical body, arcing the overlying sedimentary formations, and their diameter ranges from 1 to 8 kilometers in many occasions, and when it is moving upwards, it may move vertically, forming walls, or it may be inclined steeply, either outward or inwards. So the top of the salt dome is found to be either flat or it is domical. So mostly it is a type of anticlinal uplift, giving rise to anticlinal dome, steeply columnar structure, bulb-like, plug-like structure, or it may form mushrooms, or it may be totally detached from the source rock. And as it is a case of intrusion, the piercing structures may take any shape depending upon the condition prevailing at the place of intrusion. How is the overlying rock, whether the overlying rock is thick or thin, and whether the overlying rock is of uniform thickness. So based upon all those factors, the shape of the salt dome depends, and mostly it is anticlinal uplift, salt core. Then what are the structures that are found to be associated with salt domes? That as it is a domal structure and it is sedimentary in origin, we have the deposition of salts, deposition of sediments, deposition of shale, sandstone, limestone. In this manner, the sedimentation takes place in particularly marine environments, and therefore the associated structures which come into being because of the intrusion of salt are upward bending of surrounding rock layers, and in this condition, if the rock is pushing like this, so these sedimentary layers occurring over this intruding salt body are subjected to tension, fracturing, folding, shearing. So we find reverse faults, radial faults, normal faults, host and graben structure on the overlying rock formations. It may lead to light folding, and the entire structure of the salt dome is found to be surrounded by basins or synclines, because when this is lifted up, the surrounding areas are subjected to subsidence to form basins. So this is anticlinal uplift and surrounding areas are basins or synclines, we can say. So because of the very process of formation of salt domes, we can expect that the cap rocks show faulting, holding, host and graben structure, subsidence, and the surrounding areas are found to be occupied by basins and synclines. Now, we'll discuss how these salt domes are being produced. What is the origin of the salt domes? So, deposition of salt in form of layers takes place in marine conditions or sea basins under following ways. When a marine basin is having a restricted circulation of seawater, the salt concentrates in the solution and finally gets deposited as salt layers through the process of evaporation. A basin where the seawater is having restricted movement because of continuous evaporation, the salt in the contained water concentrates gradually and finally a stage is reached when the evaporation gave rise to deposition of salt. If there will be thorough circulation of water, then the salt content may be diluted or deposition of salt cannot be possible. So the basin must have to be isolated, or there should be restricted circulation of water, and there will be evaporation showing gradual concentration of salt in the basin, and finally a stage will come when salt will be totally deposited through the process of evaporation. Similarly, in rifted margins of the tectonic settings, the condition for deposition of salt is found to be favorable because the continents, because of tension, are found to be rifted and the seawater tries to occupy these rifts. Along with gradual rifting, the size of the rifted basin grows to form sea. So in the initial phase, when the rifting is taking place, seawater will get inside and will deposit its salt layers. Subsequently, the widening of the rift causes open sea condition and the initial salt deposits at the rifted margins get overlapped by marine sediments. So this is a process where we see salts which have been overlain by marine sediments. And similarly, in closing oceans basins, we find the salts to accumulate, salts to be precipitated through the process of evaporation. As we see in Permian salts of North German plains, Miocene salts of the Mediterranean Sea. So, salts which form an important component of the ocean water are found to be deposited under conditions of evaporation in a basin where thorough circulation of water or connection with the open sea is found to be prevented. So once salt layer is deposited and over it the sediments are being sedimental layers are deposited, that creates a condition for salt to move upwards because of its low density. Salt layers are found to have lower density, that is around 2.2 into 10 to the 3 kilogram per meter cube compared to the surrounding sedimentary rocks, where the density ranges from 2.3 to 2.8. So this is of high density, this is of low density, and this density condition prevails at a depth more than 2000 feet. And within 2000 feet depth, the sedimentary rocks have a density around 1.9 to 2.2, which is nearly same with that of the salt layers. So instability conditions or condition related to inversion in density arises at a depth below 2000 feet. And this gravitational instability causes the salt to move upwards, to flow upwards by lifting the overlying sedimentary beds or by their forceful movement through the weak planes of the overlying beds. If salt layers and the overlying strata show very uniform or regular structure with more or less a horizontal layering, there may not be any tendency of the salt to move upwards. But when heterogeneity arises in the above setting due to different causes such as tectonism, folding, faulting, fracturing, erosion of the overlying rocks, thickening of the salt layers, so these conditions they upset the balance in which the layered rocks, salt, sediments, salts, sediments that occur in layered manner, their balance is being disturbed, and we see the accumulation of salt in thick quantities with thin sedimentary strata over it. Creates a condition by tectonism, by erosion, by folding, fracturing, when the salt bodies are forced to move upward by their buoyancy. The buoyancy comes into play in salt layers because of the disturbance in the depositional environment. The salt bodies start moving upwards under the influence of superincumbent rock pressure till gravitational stability is achieved in the system. It leads to the formation of thick bodies of cylindrical salt acting off the overlying strata, and these form the salt domes or questing structures when the salt gets the opportunity to cut across the overlying sedimentary beds to form diapirs. So salt domes become diapirs when they maintain a cross-cutting relationship with the overlying sedimentary beds. The process of formation of domes creates different types of structures within the salt body and on the overlying strata through folding, faulting, tension, extension, fracturing, lifting, subsidence and intrusion. The intruding salt layers may cut across the overlying strata or truncate into the surrounding impermeable strata, creating a condition for formation of structural trap, which is commonly found to be associated with the salt domes. Salt domes present structural trap. These structural traps are of importance because they contain in them some of the economic minerals in form of petroleum and gas. So these arc-like structures or dome-like structures of intruding the salt domes are found to be eroded by percolating groundwater, particularly at its top portion, because of which basin-like structures are created on the top of the salt domes with broad sub-horizontal insoluble residue of salt at the base. Thus, salt domes, this is salt dome. So, because of erosion, because of percolating groundwater causes erosion, so we find a basin-like structure is created over the intruding salt domes. So, here it is insoluble residue of salt and here a basin is created because of erosion of salts through the percolating groundwater. This basin becomes a suitable site for accumulation of petroleum and gas. If suitable trap rock is occurring at the top, fact is that unless until there is a suitable cap rock over the salt dome, there cannot be accumulation of oil and gas. So the overlying rock must have to be impermeable. may be shell. Shell is porous but not permeable. Sandstone porous and permeable. So sandstone will not be a suitable cap rock to produce the trap structure. Shell layers which commonly alternate with sandstone in the marine conditions can be a suitable rock that can produce the condition whereby the suitable trap rock is being produced over the intruding salt domes. So the basin is created over the salt domes. Basin becomes the site for accumulation of petroleum gas, and the overlying sedimentary formations are impermeable. In that condition, the oil and gas will be stored in the basin created at the top of the salt domes. Thus, salt domes become the potential site for occurrence of petroleum and gas. Let us see what happens in a systematic way how a salt layer becomes a salt dome. Let us see here the salt is accumulated in a layer. Here we have the sedimentary formations. Disturbance took place because of this compression, because of this overlying sedimentary rocks, either due to tectonism or due to folding or due to the overload. So here there is overload, because of which these salts they try to move in this manner, forming an anticlinal structure, lifting the overlying sediments, and overlying sediment layers are subject to tension, cracks. So in this manner the cracks, normal faults develop over the intruding salt layer. So with further compaction it moves further, it tries to form a cylindrical body, folds, and the overlying sediments are thrusted, faulted, host or graben structures are being produced on the top, particularly in the cap rocks. And a condition may arise when the salt bodies may cut across this is the overlying rocks, it has cut across the sedimentary formations. So here it forms the diapir structure. So salt dome here it has been converted into a diapir. So diapir and salt domes, they are more or less synonymously used, but if you stick to the term, diapir is a structure where it is transgressive to the overlying sedimentary formations, or it is having a discordant relationship with the overlying sedimentary formations. But in case of salt dome, it is having a concordant relationship. It has not cut across the overlying rocks. So from stage 1 to stage 5, this is the evolution of the salt dome that results due to gravitational instability condition arising out of density contrast between the salt and that of the overlying sedimentary formations. And what are the economic minerals that are associated with salt domes? Petroleum and gas in the cap rock, in the flanks of the salt domes. Sulfur in the cap rock, it is found to be derived from anhydrated gypsum. What are the salts? Main content is NaCl, also calcium sulfate, gypsum and potassium salts. Calcium sulfate 2H2H gypsum, simply calcium sulfate is anhydride. So NaCl is the major component. Besides that, we have calcium sulfate, anhydride, potassium salts and gypsum. And mostly the petroleum gas which are commonly associated with the salt domes, particularly at its top under suitable structural trap condition, are of much interest and importance, because of which we study these salt domes. Where these salt domes are found? It is found in mostly marine conditions in a number of countries in the oceans. These are some of the areas where we find salt domes: North German Plain, Western Iran, Gulf Coast of Mexico, and USA. The countries around Caspian Sea, that is Russia, Azerbaijan, Kazakhstan, Turkmenistan. Beside that, we have the Red Sea area, North Sea area, Mediterranean Sea area. They are the sites of formation of these salt domes. We have West Central Africa, Canadian Arctic Islands, Romania, Gabon, Peru, France, Spain, Pakistan, Siberia, Australia, Yemen. So these are the countries, places where we find the salt domes. And the largest salt dome in the world is found at Goodrich, Ontario. So this is all about the salt domes, and I think I have tried to discuss in a simplified way what is salt dome, what is diapir, and in what condition the salt domes come up, and how it lifts the overlying sedimentary formations to form arc, and how salt is found to be deposited in form of layers, and what is the suitable condition for its accumulation and subsequent compaction to result in the development of a salt dome. Thank you.